Now see, suppose there are certain spikes on a surface and there are certain spikes on the upper surface. Okay? Like this. This is the upper surface, this is the lower surface. Now you have to slide this upper surface on the lower surface. Suppose there are 50 peaks in this irregularity, just for the sake of understanding. Suppose they are uniform, just for the sake of understanding. And suppose there are 40 peaks. Okay, now you're sliding. What is happening? The front teeth of this is a barrier for the rest of the teeth. It comes and breaks this teeth. It comes here, it breaks this teeth, breaks this teeth, breaks this teeth, breaks this teeth, breaks this teeth. And suppose there are 50 peaks. This contact area has 50 peaks. And for this upper block to get past through this much of area, it has to break 50 teeth. Okay? Now consider another situation in which the upper block has just one peak. Now suppose this was a larger area, this had a larger contact area, this one, and this one has a very small contact area, like this. So suppose it has just one peak. Now this peak will come here, it again has to break this peak, this teeth, this teeth, this teeth, this teeth, this teeth, all the teeth. So for this to get crossed, it has to break the same amount of teeth as this. So the mass that is getting lost on rubbing is the same. The rate at which it is getting lost is the same. So it doesn't have to do so much with the contact area. So that is one reason that I can offer to you. So the friction force does not depend upon the contact area. It depends only upon the normal reaction. It acts against the applied force because friction force does not want relative motion. Why? Because there is some interlockings, and that interlockings have some resistance to be broken. So either you apply force in this direction, it would not like to break, or you apply force in that direction, it will not like to break. So friction force opposes relative motion. Point number one. Point number two, it depends upon the normal reaction with the relation F is equal to mu into N. Mu is called the coefficient of friction. And point number three, it doesn't depend upon the contact area. It only depends upon the normal reaction and mu. It depends upon the nature of the surface, roughness, smoothness, whether they're dry or they're wet, but it doesn't depend upon the contact area. Okay, now let's take our discussion further. What happens when the block starts to move? When it starts to move, then friction has those interlockings that we're talking about. They have been broken. They have been broken, and now the block can move freely. But during its motion, it's not that the situation has become hunky-dory for the block. So the block still have to struggle to move further. During its journey, it has to keep on breaking the interlockings. That's the only way to move ahead. If it doesn't break the interlocking, it cannot go ahead. But once, considering the surface is uniform, once it has started, it has to break the same amount of interlockings during its course of journey. So whatever resistive force it has, that will remain constant throughout the journey. So once it has started the motion, friction doesn't become zero. There is still some resistance, but that resistance is a constant. That doesn't change during the course of motion. So the friction force keeps on increasing, and once it gets started, then the friction force remains constant throughout the motion. But one important thing is there, but during the transition from when it just gets started and to the point where it starts its full-fledged motion. During that transition, what happens, as you would understand, when it was at rest, the interlocking was strong, and when it starts motion, then the interlockings break. These teeth break, and now the teeth are more flat. You can see the teeth becomes more flat because the peaks have been broken. The teeth of upper surface will be more flat, and it will keep on getting the peaks on the way on the lower surface, but the teeth of upper surface has become more flat. So the interlockings that was strong previously would not be as strong now. So the value of friction will decrease when the body starts moving. So there will be some amount of decrease in the friction force, and when after some decrement, it would remain constant throughout the journey. Okay? Okay. So this is how the friction force acts. When you start applying force, external force, the friction force keeps on increasing up to a certain limit that is called limiting friction. This was static friction because the body was not moving. We will represent it by Fs, static friction. Now after the external force exceeds the limiting friction, then the body starts to move, the interlocking becomes weaker, and then the friction force would decrease. Once it decreased to a certain value, after that it will remain constant, because the job of breaking the peak and the teeth, that would be the same for the rest of the journey. So the friction force with a constant value would exist for the rest of the journey. So this is how the friction force varies from 0 to this portion from here will be kinetic friction, because the body is in motion. So this is kinetic friction and this is static friction. So the important thing is kinetic friction will always be less than static friction. Kinetic friction is also mu k into normal reaction. It also depends only on normal reaction, but the coefficient of friction changes. We call it kinetic coefficient of friction for kinetic friction, and when the body was at rest, we call it coefficient of friction for static friction. So this is the formula for kinetic friction, this is the formula for static friction. Both depends upon the normal reaction, but their coefficients changes in such a way that mu k will always and always be less than mu s. So that makes kinetic friction less than static friction. Okay? So those are the reasons of friction, and this is important that kinetic friction remains constant, is less than the limiting friction, and this is the formula which governs static friction and kinetic friction. So that is the introduction to friction. So that also covers the basic theory for friction. Now all we have to do is master solving problems.